If R is positive, if R is positive, show that resonance is impossible in the circuit shown in figure. So in this problem, if R is positive, you have to show that circuit is impossible. Resonance is impossible. So write the admittance for this circuit is already in ohms only. This is capacitance, reactance is inductive capacitance. So total admittance is RL plus JXL by 1 minus RC minus JXC. Here we have R plus J10. Here we have 4 minus J5. Rationalize, separate real part and imaginary part. Rationalize, separate imaginary and real part. And at resonance, equate this part to 0. Equate this part to 0. You will get imaginary part equal to 0. This you will going to get. You will get quadratic equation as R square plus 100 is equal to 80 square. You will get R square is equal to 82 minus 100. So R is equal to root of minus 18. So this indicates that thus for resonance the value of R is negative. Okay, value of R is negative. But given that if R is positive, if R is positive, it is impossible for the circuit to resonate. So because R value is minus 18 should be there, but if it is positive, it is impossible to have resonance. So next problem, a coil of 20 ohm resistance has inductance of 0.2 Henry. It connected parallel to the with 100 microfarad. Calculate frequency at which circuit will act as non-inductive resistance of R ohm. Also find the value of R. For this circuit, this is a practical parallel resonance circuit. Only inductance is having internal resistance and resistance capacitance does not have. We already derived expression for frequency of this. You can see in my previous video. Frequency of first practical parallel resonance circuit is this. FR is equal to 1 over 2 pi root of 1 by LC minus RL square by L square. RL square by L square. So substitute the value 1 over 2 pi root of 1 by LC minus RL square by L square. So how to do this I will show in the calculator. Many students they don't know how to use the calculator only. So select. I am going to divide this later. First I will do this part. So root of node 1, okay, root of 1 by LC 0.2 into 100 micro. Otherwise, this minus you cannot put here. I think what you can do is first you calculate what is the value of this first. 1 by LC is how much you calculate. After that, you calculate this, note down the answers, subtract it, then take the square root of that. Okay. I think here I tried to do directly. It's not coming. So I will do one more thing. 1 divided by R. You can do like this only. 1 divided by LC, no? 0.2 into 100 micro. This answer you have to note down. It is equal to 50,000. This value is 50,000. Okay. This value is 50,000. This answer minus, this answer minus, you have to do 20 square divided by 0.2 square. Previous answer 50,000 minus this. You get 40,000. For this, you have to take square root. Square root of the previous answer is 200. Now this is 200. This 200 divided by 2 pi. This 200 divided by 2 pi. This answer divided by 2 pi. You get 31.85. So that is resonance frequency. And after that, we have to calculate. We have to calculate the frequency at which circuit will acts as non-reactive, means it is nothing but resonance only, because imaginary part is zero, no? Because imaginary part is zero, so indirectly they asked find the resonance frequency because imaginary part is zero. And also you have to find pure resistance value. That means dynamic impedance you have to calculate. And we also derived the dynamic impedance of this one is given by L by CR. Okay, L by CR. Dynamic impedance is given by L by CR. L is 0.2, C is 100 micro, R is 20. Okay, 0.2 divided by 100 micro. This one is 100. So I will show you once again. Take this type, 0.2 divided by 100 micro into 20, get 100 ohms. So this is indirectly they are not asked to find dynamic resistance. They asked questions like find the frequency at which circuit acts as non-inductive, means circuit behaves as purely inductance resistance. That is nothing but resonance frequency to find out. At that resonance, you have to find what is the value of R. That means dynamic resistance of the circuit is given by L by CR is the answer. This answer is correct. So you have to prepare all the questions so that you can answer any question.